Hi, my name is Jacob Schramkowski, and my partner is Patrick Day, and we're in Project Team 35. And for our project, we made a ball rolling game where you tilt the board. Oops, I should reset. Where you tilt the board and you have to guide the ball into the objective, which is a green flag, and there are these red walls that you have to get around by tilting the board. Um, so just a couple things to note here. One of the things that makes our game unique is that we're not using the accelerometer in a trivial way. We're kind of using it for the entire um, way that the user actually interacts with the game, and it's pretty much running a physics simulation. So, when I tilt it down quickly, it will move a lot quicker. If I'm holding it pretty, you have to hold it very horizontal for it to not move. And then within that, we've also got collisions, so it'll collide with the walls and also the edges of the LCD screen. So it makes it feel like a very kind of believable rolling ball rather than just kind of moving by one pixel at a time at a constant speed. It's a lot more fun this way. So, and then we have a couple of different levels. So when I move over here, it plays that tone. That means you've finished the level and then moves on to the next one. So if I finish this one here, I'll move on to one more. And hopefully I'm able to do this one. It's one of the tougher ones to do with one hand, especially since I'm filming with my other hand. Here we go. And then this is just the last level. We've got the 4 levels, and then once I finish it here, it'll just go back to the first one. So that is kind of the normal mode, and then when I turn on my phone flashlight here, hopefully you can see it, the ball turns to a purple color from its default blue. Oops, I think I messed up the power. There we go. Yeah, so, oh boy. Okay, so yeah, the light sensor, if it's above a certain threshold, will turn the ball purple, and maybe you can tell that it bounces kind of a lot more and has a higher level of gravity. So it makes the game a little bit more challenging, and it bounces quite a bit more, and you have to be a little bit more precise with how you handle the board in order to make it actually go to the correct spot. So if I turn it back off, it should kind of slow down quite a bit right away. There you go. Okay, so I'll just quickly go over the tasks that we're using. There's only 4 of them. One of them is a loop for getting the accelerometer reading values, and then we have a bottom half for the analog to digital conversion of the accelerometer reading. Then we have another one for the buzzer, and the last one is a loop for drawing the game. So I'll just start from the top. So the accelerometer timer task here, all it does is it's in a loop. It'll wait 1 millisecond and then start another accelerometer conversion from the A to D converter. And then that'll come down to the, well, it'll generate, first of all, a timer interrupt, and then, excuse me, it'll generate the analog to digital interrupt, and then we're handling it down here. And from here, we just grab the X, Y, and Z axes from there. Even though we're not using the Z axis, we still grab it. And then we're sending a notification to the bottom half of that task. So that is here. And then from here, we will take that notification, we generate a new message object here, set its X and Y values to what we got from down here, so X and Y, and then we send that to our queue, and this is the queue for all of our movement commands. So when you tilt the board, you generate more and more of these messages, and then they get sent to the queue, and from there we intercept them in the task game draw, which is drawn over and over again in a loop. So the first thing that we do in that loop is we receive a new movement message in using the queueReceive method. And so that puts it into this message variable, and we get an X and a Y acceleration. And from there, we use that to update our ball in the physics simulation. As far as the rest of the things going on in here, we'll just quickly go over. So we're reading the lux level from the light sensor and checking if it's above a certain threshold, and from there we actually set different parameters for the ball. That's what changes the color and the amount of bounce and the gravity and all of that. And then we do have a delay to keep this running at kind of a roughly 60 frames per second, but that doesn't account for the actual time it takes to draw any of this, so it's kind of off. But anyway, so then we go down here, we were using our LCD draw image to draw the ball, and then there's also in this restart level, we also draw the objective, so that draws our flag. And then going to the buzzer, we have this buzz method, which is used again in this task game down here. So when the ball comes into the objective, we'll buzz 3 tones, and this method is declared in our buzzer file. So this uses the a task notification. It goes to the buzzer. So the buzzer bottom half will intercept that notification and then set the new pitch of the buzzer to our argument from here using the buzzer period and then duration. So then this task will turn the buzzer on, wait that amount of time that we set, and then turn it back off. And then you can see that there's this Boolean here for whether it's buzzing or not. That is just used in order to make this a synchronous method. So it waits while it's still performing that buzz that we set it to, so that you can actually come in and do 3 synchronous buzzes rather than if that's not there, it'll just overwrite whatever the previous tone was and only play 1 tone. And so that's pretty much it for our tasks. We went over the accelerometer and the buzzer and the game. So yeah, thanks.